In this video, I'm just going to talk through 2015 mock paper 1. I'll spend some time in the more difficult parts and just fly through the simpler ones. So question 1A, part 1, is to plot Z and 2IZ on the Argand diagram. So if you look at Z, they say that it's the complex number 2 plus I. So we would go out 2 on the real axis and it's 1I. So I've gone slightly too high. It should actually just be where that red dot is hovering now. So that would be 1I. Then for 2IZ, so I have that written out here. 2iz is the same thing as 2I times z, which is the complex number 2 plus I. So I multiplied it out. Let I squared equal -1. So instead of I squared, I put in -1. So this changed to -2. And then it's easier to graph if you just change it around so that it's real plus the imaginary. So then I would go out -2 on the real axis and then up to 4I and label that. So part 2, find the value of. So this is the modulus. So those bars 2iz are inside mean modulus. So the modulus of 2iz divided by the modulus of z. Now the modulus is the distance. So if you look at the graph here, it's the distance of the complex number to the origin 0, 0. So that would be the modulus of z. And then from here to 0, 0 is the modulus of 2iz. So I've worked these out separately here. You just have to be careful when you use this formula for modulus, it's a squared plus b squared. There's no I put into the formula there, okay? So you literally just take the number. So a here is -2, b is 4. And then over here, I put them back together. So the square root of 20 over the square root of 5 into the calculator, and that gives you 2 for your answer. So then part 3, what does your answer in part 2 tell you about the relative positions of z and 2iz? So I said that modulus is the distance of a complex number from the origin 0, 0. So if you look, the answer that we got was 2. The question initially asked us what is the value of, so this is like a ratio. So this is 2iz divided by z. So it would tell us that 2iz is twice the distance from the origin of z. You can kind of tell that from the graph, so you can have a guess at it. So then part B, find z conjugate. So the z with the little hat is the conjugate. Find z conjugate divided by z. So if z is 2 plus I, the conjugate is found by just finding by changing the sign in front of the imaginary part. So it was positive, it changed to a minus. So then over here, I've said 5. So z conjugate is 2 minus I divided by z, which is 2 plus I. Multiply it out to make it a bit simpler. So now in complex numbers, we can't actually divide by complex numbers. So what we do is we multiply the top and the bottom of the complex number by the conjugate of the bottom. So the bottom here is 2 plus I, so the conjugate will be 2 minus I. So now I've just jumped to the answer here, but if you go to the 14th slider to the very end of the video, you'll see all the workings as to how I multiply that out. With these, what should always happen on the bottom, so when you multiply a complex number by its conjugate, you should always get a real number on the bottom, so you'll never be left with an I. Okay, question 2, express 340 as a product of prime factors. So to break something down by prime factors just means to multiply it by all the primes that will divide into it nearly. So look at the prime at the number that you're given and divide the smallest prime number that you can into it. So start at 2, then try 5, and just work your way up. So what I've done here is I said it's 340 divided by 2, which is 170. 2 will divide into that again, leave me with 85. Now 2 won't go into 85, so I went on to 5. And then when 5 went in, it gave me 17. Now 17 is a prime number, so you can just divide 17 by itself. And then it's just the product or all of these numbers here multiplied by each other is your answer. B part 1, for each of the numbers in the table below, tick the correct box to say whether it is rational or irrational. So that's just, if it's rational, it can be written as a fraction, and if it's irrational, it can't. So you could put that into your calculator if you weren't sure, and you could just, like, if you put 0.25 in the calculator, it will change to a quarter using that S to D button. And then say for this one, this wouldn't change into a fraction. I know it's technically written as a fraction there, but on a calculator that wouldn't be able to do without the pi. Same for the square root of 2. So then it says write each of the rational numbers in the form a over b and write each of the irrational numbers as a decimal corrected to 2 decimal places. For that, you can just use your calculator. Just put it into the calculator and use STD and write down what you get. And just being careful to do the decimal 1 to 2 decimal places. Okay, C, the speed of light is 299,792,458 meters per second. Write this number in the form a by 10 to the n. So a, when you're doing scientific notation, which is what this is, a needs to be between 1 and 10 always, and n has to be an integer. So it can be positive or negative, but it wouldn't be a fraction. So it's correct to one significant figure. So We'll look at that at the end. So all we do is we write out the number and we put the decimal point at the end. Then the decimal point is going to jump to the left all the way back just to before the very first number. So it's jumped 8 places here. So that's where the decimal point now drops. So I've just rewritten this as 2.9979. And now it's by 10 to the power of 8. So the number of places that the decimal jumps, that gives me that little n there. That tells me the power of 10 is 2. Now, it wants it to one significant figure. So I'm just going to look at 2.9. So if you want one significant figure, just look at two of the numbers. So it's 2.9. 9 rounds 2 to 3. So my answer is 3 by 10 to the power of 8. Question 3, solve for x. So what you have here is an inequality. The only thing you have to be careful of with an inequality is that if you multiply or divide by a negative, that you change the direction that the inequality faces, but we shouldn't have a problem here. So all I did was I multiplied out the bracket first of all, so 3 times 2x was 6x, 3 by minus 5 is minus 15. Then I just did a slight bit of rearranging to leave the x on its own and bring all the numbers to the other side, divide both sides by 13, and then x is less than or equal to 2. B part 1, so write that as a single fraction. So when the bottom is an algebraic fraction, so here it's x plus 4 and 2x minus 1. So usually we're looking to find the lowest common denominator, but we can't do that when there's an unknown x. So simply the new denominator is going to be the bottom of the first fraction times the bottom of the second fraction. And then you can just do a small bit of cross multiplication. So here 2x minus 1 multiplies by 4, which I have here. And then x plus 4 multiplies by 3, which I have here, and the minus sign carries down. You just multiply out the brackets and then leave the bottom as it is. Don't bother multiplying the brackets on the bottom. So hence show that that equation there has no real solution. So you'll see that this is the same as this one up here. So all I did straight away was instead of what they've given me, I changed it for my answer. So I want to show it has no real solution. So what we're going to use here is a thing called the discriminant. So if you remember the minus b formula, under here, so I'm just showing you here, under the square root of the minus b formula, it was b squared minus 4ac. If you want to show that some equation doesn't have any real solutions, you show that there, b squared minus 4ac is less than 0, and that'll tell you. So the first bit of work I have to do, so I changed out that equation for my answer from part 1, and I let it all still equal 1 because it's the same equation. I did a small bit of cross multiplication just to get rid of the fraction on the bottom, and then multiplied out this bracket here, and then rearranged it so that at the end I ended up with a quadratic. So to test the discriminant, you need to end up with a quadratic. So now with this x squared plus x plus 6, I just find out, so a is the number in front of the x squared, b is the number in front of the x, and c is the constant at the end, same as you would for the minus b formula. Subbed it into that there and got minus 23, which is less than 0, so it has no real solutions. Question 4, so that's a functions question. So you're given the graph of 4 quadratic functions. And which of the graphs above is that of the function f of x is minus x squared plus 5. So where x is a real number, and you have to justify the answer, so you have to give them a reason as to why you think that's it. Well, straight away, it's minus x squared, so I know it's not going to be either of these U-shaped graphs because they have positive x squareds, whereas we have a negative. So I know it's going to be one of these n for negative graphs. The next thing that I'm going to look at, where does the constant of the graph lie? So it says minus x squared plus 5. Now, it's not very clear. This one here looks to me like this is passing straight through 5. So this is most likely going to be my answer. But if you look at B, it's not particularly clear at the moment. So I'm just going to check a little bit more just to make sure that it definitely is graph C. This is the one that we're leaning towards. But the easiest way to say that it is graph C is to prove that definitely it is not graph B. So if you look at graph B, it passes through 0, 0. You can see that it's clear. So what I did was I took the point 0, 0, I subbed it into minus x squared plus 5. And just don't forget, if you look up here, this f of x maps onto basically how this reads. This is the same thing as f of x equals. And f of x also means y. So what I did here was y is 0, so 0 equals minus, instead of x I put in 0, to be squared plus 5. So 0 doesn't equal 5, so you've shown now that B is definitely not the graph, so therefore C is the answer. So B, the diagram shows the graph of 2 quadratic functions g and h defined for x. So part 1 says to use the graphs to find the functions of g and of h. So if I start off maybe with g, it's probably a bit simpler. So g is u-shaped, so you know it's going to be a positive x squared. To find the graph on any of these functions, what you need basically are to find the two roots, and the roots are where it crosses the x-axis. So if you look at g crosses there. So I'll actually mark it. G crosses just there at 1 and there at 4. So they're the two roots. So then if you were to look over here, I have the roots are 1 and 4. If you have the roots, so if you know x is equal to 1 and x is equal to 4, you can then find the two factors. So all that happens is the 1 jumps over the equal sign, so it's x minus 1 equals 0. Same here, 4 jumps over and it's x minus 4 equals 0. I multiply the two factors by each other. So I have that done here, and that gives me the equation of g of x squared minus 5x plus 4. And I know I'm right because it's a positive. You can see there it's a positive x squared. So now I'm going to do h of x. So h of x, again, I want to find the roots of h of x. So where does it cross that x-axis? And it does it there at minus 1 and again at 3. So you'll see then that the roots are minus 1 and 3. So then the factors are going to be x plus 1 and x minus 3. Again, I just multiply the factors by each other. You'll see that what happens is you get x squared minus 2x minus 3. This is where your knowledge of what a graph should look like kicks in. So you know because h of x is an n, that x squared should be negative. So what I've done is I've multiplied across by minus 1. So the plus x squared became minus 2x became plus 2x, and minus 3 became plus 3. And then that flips it into the correct graph. Part 2, use the graphs to estimate the values of x for which g of x equals h of x. So g of x equals h of x where they cross over, where they have points of intersection. So if I get rid of some of this, you'll see then that the points of intersection of these two graphs are just here and here. And then what it says is to estimate the values of x, you go to that point of intersection and then you drop down onto the x-axis and you tell me the value there. So I've estimated at 0.1. So just somewhere, it's clearly not a half, just be kind of sensible with your guess, but you'll get the marks if you're close enough. Then this one here, I've estimated that's at 3.3. And I've just written them as x equals 0.1 and x equals 3.3. The third part is to verify your answer algebraically. So g of x equals h of x. So just, we know the function or the equation for g of x, we got it up here, and we know it for h of x. So I've just let one equal the other. Then I've done a little bit of rearranging. I've brought everything from this side. So I brought the x squared, the 2x, and the 3 all over. I've simplified that to get this quadratic equation. And then I have done the minus b formula. So by doing the minus b formula, I'm going to find the two x values for this equation. Okay, so I did the minus b. Again, b is, I made a little mistake there. B is minus 7. B should be minus 7. I have it correct there, but just forgot it there. C is 1 and A is 2, and I subbed it in and got the two values, and you can see that they are very close. So question 5, so they give you f of x, this function, and they say find the derivative of f of x. So it's a differentiation question. So I've just written out the original equation here. Now f of x is the first derivative. So don't forget to differentiate. You drop the power, so the 3 comes down, and then you take 1 off the power, so it becomes 2. Here, you drop the power, so when the power comes down, there's already minus 6 there, so it's 2 times minus 6, which is minus 12. And then you take 1 off the power, so it just becomes x to the power of 1, which we don't really ever write, so it's just x. And then if it's just 9x, that just differentiates to 9. Anytime it's just 9x or 6a, so 6a would differentiate to just 6, 9x would just differentiate to 9. So then part B, so find the coordinates of the local max turning point and local min turning point of the function f of x. Okay, so to find turning points, the first thing you need to do is you need to find the first derivative, which we've done in part A. Then for the second part, you take that first derivative and you let it equal 0. So I've written it out here equal to 0. And just make it a bit simpler, I divide it across by 3. So I have x squared minus 4x plus 3 equals 0. Now this here, you can solve that using the minus b formula, but it was quite simple, so I just guessed, trial and error, did the answers here. So if you look there, so minus 1 times minus 3 gives me plus 3, and I would get minus 1 minus 3 gives me minus 4, so I know that that's correct. So I have the two factors here, and then I just solve them. So x minus 1 equals 0 tells me that x is equal to 1, and x minus 3 equals 0 tells me that x is equal to 3. You take these two values for x that you found, and you sub them back into the original. So you go back to the f of x at the very top of the question. And then, as I said before, f of x is y. So when you sub x in here, you find f of x or y. So I've done that out here. So when x is equal to 1, y is 4. And when x is equal to 3, y is 0. So I have these 2 points. So 1, 4, and 3, 0. The last part then is to tell whether local max or local min. I just did a little quick sketch of where the 2 points would lie. So I see that 1, 4 is up way higher than 3, 0. So that would make that the max. So without sketching the curve, you can just plot the points and figure out where it lies. So then C says, using a sketch of the graph or otherwise explain why the function has only 2 solutions. Now, the reason it only has 2 solutions, you don't even really need the graph. The reason it only has 2 solutions is if the turning point, so we have here that the local min, which is a turning point, if that's on the x-axis, it will only ever have 2 solutions. So you can just know that, but they do want to see a sketch of the graph. So I just went and checked if the origin lay on the graph, and it did. That's the other point on the x-axis. So I went and I checked that. And then with them 3 points, I just sketched it out to look like that. You wouldn't need to do this arm up here. I just know it will jot up there because it's a cubic graph. But you get away with just finding one extra point and just doing the curve like that. So question 6 is an indices question. So A says to write 125 to the power of third as a whole number. So you can ignore the power for the moment, just look at the 125 and see, can you write that as a number to a power? So I got it down to 5 to the power of 3. Again, you can kind of use your calculator to mess around with this. You can start dividing factors or things that divide into 125. You can start dividing it in and see how many times it divides in. So then I know 125 can be written as 5 cubed or 5 to the power of 3. So instead of 125 here, I put in 5 to the power of 3. And then using the rule of indices, which says if you have 5 to the power of 3 all to the power of a third, you just multiply the two powers. So 3 by a third gives me 1. So 5 to the power of 1, that's a whole number. This one then, write 8 times 4 to the power of minus 3 as a fraction. So again, I'm going to change that 8 and that 4 so that they have a similar base, and the base is the big number. So if you look here, 4 is the base and minus 3 is the power. So 8 is handy enough. It can be written as 2 to the power of 3. 4 to the minus 3 is a trickier part. So just look at the 4. 4 is the same thing as 2 squared. And it's always a good idea if you can get these to match. It makes life a bit easier. So it's 2 squared to the minus 3. Again, using the same rule from up here, I multiply the power. So 2 by minus 3 is minus 6. So now I just go back to the original question that they gave me, and I'm just going to change. So I know that 8 is the same thing as 2 to the power of 3, and 4 to the minus 3 is the same thing as 2 to the minus 6. Now, because the base is the same, and it only works if the base is the same, I can now just add or subtract the 2 powers. So it's 3 take away 6, which is minus 3. And again, they had to both be 2. You can't do it up here with the 8 and the 4. So I have 2 to the minus 3. Bring the 2 to the minus 3 under the fraction line here, and it changes to a positive. And then that changes to 1 over 8, which is that written as a fraction. So B is a bit more difficult because B is just in general terms, so there's an A instead of a number. It looks more difficult, but it's actually simpler because the base is straight away the same. They're all to the base of A. So if you just look at the top here, straight away, that's A to the power of 3 times A to the minus 1. Because the base is the same, I can just take away the power. So 3 minus 1 gives me 2, and the bottom stays the same for the moment. Now, it wants it written as a fraction with just 1 on the top. If I bring this A to the minus 2 underneath the fraction line, I leave behind 1 because you wouldn't really see it, but just there'd be a 1. So if I bring the A squared under, like I have done here, it becomes A to the minus 2 and 1 on the top. And then you'll see then that I just said, okay, they're the same base. So again, I'm going to take away the powers. 5 take away 2 is A to the 3. And I've written the rules over here on the side, but just remember that they're all in your log tables. Okay, so solve the following equation. So it's 2 to the 3x equals 32 to the power of 3/5. Now again, remember, if the bases are the same, I can do a lot more with these. Mainly, if the bases are the same, so if this was 2 and this was 2 to the power of something, I can actually just drop the base and I can just work with the powers. So this is fine. So I'm going to see, can I write 32 as 2 to the power of something? And I can, because 2 divides into 5 times. So 2 to the 5 still all to the power of 3 over 5. Now, I've just multiplied here. So like I said before, there's a rule that says you can just multiply 5 by 3/5. So that leaves me with 2 to the power of 3. Now, because the base is the same, I literally just drop the 2's and get 3x equals 3, divide both sides by 3 and get x is equal to 1. Okay, and this one, 5 to the 2x minus 1 equals 1. So again, it's the one that's causing an issue. I'm going to try to write that as 5 to the power of something. 5 to the power of 0. If you do any number to the power of 0, that's the same thing as 1. You can check it on your calculator. So I've rewritten that as 5 to the 2x minus 1 is equal to 5 to the 0. So then I just drop the bases. So I get 2x minus 1 equals 0, and then rearrange it so that x is a half. Okay, so question 7 is a financial maths question. So there's a lot of reading there. I just went through and I highlighted some of the most important stuff. So Anne is looking to save for her pension. She wants to put in €400 per month. She's going to add €5 extra per month. There's no annual payments of interest, so there's no interest being added on at the end of each year, at the start of each year. But at the very end, she'll get an additional payment of 65% of whatever she invested on the date of her retirement. So it says these contributions can be represented by an arithmetic sequence. So again, a lot of this is in our log tables. So complete the table showing Anne's monthly contribution for the period shown. So in the first month, she just puts in 400. Then after that, she's going to increase it by €5. So the first few months are handy. So at the second month, she's going to put in €5. So it'll be up to 405. Third month, another €5. Fourth month, another €5. It's the 12th and the 24th month that will be more difficult. So it says here that she does it at, where did it say? It said somewhere at the start of the month, but anyway, so she's going to increase these payments by €5 per month. So to find the 12th month, you'll see over here I have it done. It's the 400 that she initially put in plus the 11 months prior times 5. So that's where I got the 455. So to do this one, then it'd be the 400 that she put in plus 5 times the 23 months prior, because if you did 24, that'd be like the extra month's payment. So part 2 says, find in terms of N a formula that gives the value of Anne's monthly contribution in the nth month of the scheme. So again, you're going into your log tables and you're getting this formula here for the nth term. So it's A plus N minus 1 to the D. So A is the principal amount or the present amount, whatever she puts in at the start. And then N would be the number of months, but we're not sure what that is yet. And then D is the common ratio, or it's whatever she's putting in to increase that each month, which is €5. So instead of A, I subbed in 400. Instead of D, I put in 5. Multiplied out the bracket, so 5 times N is 5N. 5 by minus 1 is minus 5. And then I just tidied it up to get this. Another word for that D there actually is common difference, but I just think about it as it's whatever they put in themselves to increase it. So part 3 is find in terms of N a formula that gives the value of Anne's total pension contributions from the first to the nth month of the scheme. So again, you're going to your log tables and you're getting this one here for the sum of her total contribution. So N, again, we're not sure of, that's the number of months. A is the first or the present amount of what she puts in, and then D is a common difference or how much she bumps it up by. So I've just subbed in, so I've left N as it is. Instead of A, put in 400, and instead of D, I've put in 5. And then I've just simplified in that little bracket a bit. You could go a bit further, but there's not really any need. So then part 4 is using your formula or otherwise, find the total value of Anne's pension fund on the date of her retirement. So we're going to use this formula that we just came up with there. We didn't even come up with it, we just kind of sub stuff in. So the only thing now that we need to know is at the end of her savings, so when she retires, what is N? So how long has she been doing this for? So it's 30 years, it says in the first line of the question, which is 360 months. And we're going to change all this into months because she was saving monthly. It will be different if she was saving annually. So the N is 360. And again, you see up here, I just put in 360 instead of N. And that gave me this figure here for 167,100. Now she does get an additional payment of 65% of the sum that she invests. So then over here, I took that sum that she invested, found 65% of it, added that on, and then this would be her pension fund at the end. Okay, so same question carried on. So Beth agrees to invest a fixed amount of money every year, so she won't be increasing it. There's an inflation adjusted annual growth rate of 4%, so there is some interest rate. So in the table below, write down the value of Beth's first contribution of P after each of the time intervals shown. So we're not actually sure what it is that Beth will invest every year, but because it's constant and it won't change, we can use the compound interest formula. So I just have that written out here. So the final amount equals P, present amount, or what you put in at that time, times 1 plus I, the interest rate, all to the power of T, the time. And we're just going to rewrite that. So it tells us that the annual growth rate is 4%. That as a decimal is 0.04. So you can see for 1 year, I've just subbed it in. So P is what we don't know. So it's P times 1 plus 0.04, all to the power of 1. Simplified, it looks like this. The only thing that changes here is the T. So I've done it for 5. So instead of T, I put in 5. And then instead of T, or I just left it as T and filled it into the table. So part 2, the total value of Beth's pension fund after T years can be represented by that sequence there, which is, you can just see that's year 1, year 2, year 3, all the way up to year T, and times by whatever principal amount she puts in. State whether the total value of the fund can be represented by the sum of an arithmetic or a geometric sequence. So that is going to be geometric, and that's because it increases by a common ratio. So you can see that it goes up in powers, and that's a good hint that it's a geometric sequence. So these are all multiples of 1.04. So that's 1.04. That's it by itself twice, 3 times, all the way up to T times. So that's geometric. So part 3, the total value of Beth's pension fund after T years can also be calculated using that formula. So they say I is the interest rate. So she makes 30 annual payments of £6,000 at the start of each year from now until her retirement. What will the value of her pension fund be when she retires? Give your answer correct to the nearest euro. Okay, so P, the principal amount that she puts in is 6,000. Here, I, the interest rate is 0.04, and T is 30. She does it every year, so we don't need to change that to months. We've just subbed it all in, and then I put it into the calculator. Just be very careful with the calculator there, like break it into smaller sections if you need. C, give a reason why Beth's pension fund will be substantially less than Anne's pension fund after 30 years. Well, that's because Anne is increasing her monthly contribution, whereas Beth is just putting in the same amount every year. So question 8 is another financial maths question, and it's on income. So Kira works as an accountant, and it just goes through the taxes that she paid. And again, I've just highlighted the important part. So her gross monthly salary without tax being taken off is 4,800. So up here then we have the standard rate of income tax, is 20%, and the higher rate is 40. She has monthly tax credits of 275 and the standard rate cut off of 2,817. So how much income tax does Kira pay each month? So we're going to do this in a couple of steps. So this standard rate cut off point, so this means anything you earn up to 2,817 euro is taxed at 20%. Anything you earn above 2,817 euro is taxed at 40%. So I'm going to do the 20% one first, and these are the same kind in all the questions. So 2,817 by the 20%, so she pays €563.40 on the first 2,817 she earns. Now we need to figure out the higher rate. So this is what she earns a month. You take away the cut-off point of 2,817 and you find 40% of that. So 40% of that was €793.20. You add together the two tax rates that she pays. I got this figure here. And then you take away her tax credit. So it's €1,356.60, take away 275, which again is in the question. Take that away, and that tells you the income tax that she has to pay each month. So part 2, so this is about USC. So she pays USC at the rate of 1.5 on the first €1,001, 3.5 on any earnings between 3.5 on any earnings between €1,001 and 1,465, and then 7% on the balance. You're going to have 3 calculations here, 4 really, and we need to calculate the USC that Kira pays. So we know from the question that she pays 1.5% on the first €1,001. So you find that in the calculator and you get this figure here. And again, I know I have 3 numbers after the decimal point, but until the end of the question, don't round anything. Now, she pays 3.5% on any amount she earns between €1,001 and €1,465. Now, we know that she pays 4,800 or earns 4,800 a month, so she's definitely going to be in this bracket. So I take one cut off from the other, get 464 and find 3.5% of that. So again, this whole part here comes from the question. This is nothing to do with Kira really. And then she pays 7% on the balance. So the higher cutoff here is 1,465. Kira earns 4,800, so I take that away, and then I find 7% on that, because that's basically everything that she earns above that final cutoff. And then I just add together my three answers and then round it to get €264.71. So part three, Kira's monthly take-home pay is €3,261.69. You need to find the percentage rate at which Kira pays PRSI. So I've just written down the formula for take-home pay. So take-home pay, and it's basically just your gross pay, so what you earn before tax, minus net tax, which is basically your income tax, plus the USC, plus PRSI, it could be plus pensions, but it's just anything that you deduct or take away from the gross pay goes in here. So the take-home pay from the question is this figure here. Gross pay again from the question is 4,800, and then it's minus, so the net tax we got in part one, so that was the income tax, plus her USC, which we got in part two, plus we don't know how much PRSI she paid, so what we're looking for, so we leave it blank. So again, I've just added these two figures together and got this number here, and I've dropped the bracket, so that became a minus, and it's minus the PRSI. And now I've done a little bit of algebra and a little bit of rearranging. So I've brought the PRSI over the equal sign, so it's here now. I've brought this figure of €3,261.69 over this side, so you can see here it becomes a minus. This I've popped into the calculator, and I've got that PRSI is €192. That's how much she pays, but we need to figure it out as a percentage rate. So I've taken the amount of PRSI she pays, divided it by her gross income, because it's a percentage of her gross monthly salary, and multiplied by 100 to get 4%. Okay, part B is a foreign exchange. So she has a credit card with a limit of 3,000. Interest is charged monthly, and the AER, or the rate that's charged at, is 18%. So for part one, it says that she bought a new suite of furniture costing 1,975. If the exchange rate was for every €1, you get 0.8374 pence. Calculate to the nearest cent the amount that will be included on Kira's credit card bill. So for that one, literally all I had to do was to convert it. So I took the 1,975, divided it by the by the exchange rate, and got 2,358.49. You just need to then be careful when you round the decimal here. Round it off to 2 points for money. You didn't have to do anything else actually in that question. When you're going from a foreign currency back to euro, you just divide by the rate. So you take the foreign currency divided by the rate, and that puts it back to euro. So for part two, given that 1 plus r, so r is the rate, to the power of 12 is equal to 1 plus I, which again is an interest rate, where r is the monthly rate and I is the annual rate. Find the rate of interest charged on Kira's credit card, compounded monthly, which is equivalent to an AER of 18%. So you're basically finding the equivalent rate, and these questions come up a lot. So the first thing you do is you just take down the formula as it stands. For these, when you're asked to find an equivalent rate, you don't ever know R. R is what we're looking for. And then I is the interest rate they give you in the question, which here was 18%, and I just changed to 0.18 because we always work with the decimal. Now just sub in what I know. So it's 1 plus R to the power of 12 is equal to 1 plus 0.18. Tidy it up a little bit here. To get rid of this 12, I'm going to raise this whole side to the power of 1/12, because if you have 12 times a 12, it goes to 1. Now, if you do that on this side, you need to do it on the other side as well. So raise it to the power of a 12th. I can drop it there. So basically it cancels out there and leaves you 1 plus r. When I put that into the calculator, this is the value I got here. Leave r where it is. The 1 jumps over to become a minus. And you end up with this figure here, 0.01388. I multiplied by 100 to get it to a percentage, and then you just be careful when you're doing it to 3 decimal places. So you can see there, multiplied by 100, the decimal place just goes 1, 2, 3. That's actually too far by 100, it's only 2, so 1, 2 just drops in there between the 1 and 3. So you get 1.388, and that rounds to 1.389. So part 3, so Kira's financial circumstances change. She's unable to make any repayments. So assuming she makes no more purchases on her credit card, show she will exceed her credit card limit after 18 months. To do that, you have to show that on the 17th month she still hasn't exceeded it, and then it doesn't get exceeded until the 18th. You wouldn't get full marks for only showing the 18th month because she could have gone over in 17th month. So you kind of have to prove both. So again, I'm just going to use the compound interest formula for this, because it's like with the pension one, that woman in the pension question wasn't making any contributions. Beth, whatever her name was, she wasn't making any extra contributions, so you can use it when it's fixed amounts like that. You can use the compound interest. So at 17 months, we know that the only thing she's bought is that sofa. So the balance is up here. So that's the present value on the credit card times 1 plus, we now know the equivalent rate. So the AER, we don't actually use the AER in questions, we have to use this equivalent rate. So again, I went back to the decimal version, and at that T of 17 months, that goes into the calculator, and you can see that I got less than 3,000. So she still hasn't gone over the credit card limit. Now we go up to 18 months. So again, she still hasn't bought anything else on the credit card. She hasn't made any repayments either. So it still is at this amount. It's just that sofa on the credit card. 1 plus the same equivalent rate that we got in part 2, and now we're at 18 months. The only thing changing is the time, and you can see when that goes in the calculator, you've exceeded the credit card limit, so it was at the 18th month. So question 9 is another functions question to do with graphs. So in 2014, 5 people represented Ireland at the Winter Olympics. One of these took part in the snowboarding slopestyle competition. The event consists of a series of jump ramps on a downward slope, in which the competitor don't even matter. The curved surface of a jump ramp is modeled in the shape of a quadratic function. So the height of the curved surface, or the height of the graph there, is given as x squared minus 6x plus 9. So h is the height of the curved surface, so of the ramp, in meters, and x is the horizontal distance in meters, so that's how far basically the ramp goes on. So then A is complete the table below showing the height of the ramp at the indicated points. So they've given you all the values for x, and you can see there I have an example. So when x is 0, you just go back to that h equals x squared minus 6x plus 9, and you sub in 0, and you get that y is 9. So like I said, when f of x is 0, h of x can be 0, g of x, it doesn't matter. It's just some function of x. So you just sub in 0 instead of 9, 1 will give you 4, 2 gives out 1. So then B, using the coordinate plane where A is the origin, show the curved surface of the ramp. These here are all the points in that graph. So if you look, this is the point 0, 9. So you start here, down here on the graph at 0, up to 9. Then it's 1, 4. So out to 1, up to 4. 2, 1. So 2, out to 1. Now I just sketched it. I should have done a bit better. Then here at 3, 0. So you just got to plot all these points down here, and then make sure you label it h of x. So C part I then is to find dh dx. So again, h from the last question is x squared minus 6x plus 9. dh dx is just the derivative of it. So again, the 2 drops down, so it becomes 2x, reduce the power by 1, minus 6x, again we said it was just x, it just goes to the constant, so minus 6, and this 9 is gone. So dh dx is 2x minus 6. So part 2, does the ramp meet this slope criteria? So it says the slope criteria says up here, the slope at the takeoff point should be almost vertical, so it should be almost standing up straight. So the easiest way to do this then is to look here at the derivative. Now, if something has a slope, almost vertical slope, it would be 0. So what I've done there then is I've said, okay, so h of 0, so let x be 0, and that comes out with minus 6. This was a little bit tricky. You had to kind of find the angle of the elevation. So I took the inverse tan of the minus 6, and that got me to 81 degrees, which is almost close to 90, so it's almost vertical, so it basically meets the criteria. I wouldn't worry if you couldn't get that, it was quite tough. So the slope of the in-run, the downward section leading into the ramp, which allows snowboarders to build up speed, is a half, so the slope is a half. To achieve a smooth transition between the two, the in-run is tangential to the curved surface of the jump ramp. Find the coordinates of the point at which the in-run is a tangent to the ramp. So this is a question that you do in your book. So what you literally want to find first is the derivative of h, which you already have. The second step is to let that derivative equal the slope that they've given you, and you solve for x. So it's very like the questions when we found the turning points way back, the local max and the local min, except when it's local max and local min, you let it equal 0. But here it's a different kind of turning point, and they've told us what to let it equal. So it's not 0 here, it's a half. So I let it equal a half, and I solve it for x, and I get x is equal to 13 over 4. Then I go back to the original h function, and I sub in 13 over 4 for x. So then this is the x coordinate, this is the y coordinate, and that's the coordinates of the point they're looking for, tangent to the ramp. On the coordinate plane, show the line that represents the in run. So if you go back to that previous page with the graph of the horizontal, you'll see that I've drawn the in run there. Now if it's a half, it should just be kind of slightly tilted up, and then I just drew a line through that point basically. Part 3, so find the equation of the line that represents the in run. So a little bit of coordinate geometry here. So this formula here for the equation of a line is in your log tables. Thing you need to make it work is this point x1, y1. They've given you the point, which you've just found up above, and they've given you the slope. The slope is a half. So you've just got to sub in. So this here, 1 over 16 is y1. M is the slope a half, and x1 is 13 over 4. So that subs in there. And leave it like that. It doesn't say it needs to be in a specific form, so you're only going to make mistakes because of all of the fractions, so I'd say just leave it as is. So that's the end of that paper 1. You'll just see there I've just done out the entire question 1 part B, just so you can see the steps involved. And then for that one where it was about checking the graph to pick which graph, question 4a, I've just done another example. So if you see there, I've subbed in 0, 0 to show it's not on the graph, and then I've picked a point and see it showed it is on the graph. So just went for that proof a little bit.